This video will be about exponential expressions. So for this section, they mostly focus on two rules. The first rule is that anything raised to the 0 power is 1. Anything at all, 100, negative 5 billion, all of it raised to 0 is 1. The second rule is if you have anything raised to a negative number, what it's going to do is turn it into a fraction if it isn't already 1, and move this to the bottom of the fraction. So when we turn something into a fraction, we put it over 1. These are going to flip. 1 would be the top of the fraction, x to the third would be the bottom, and when you do that flip, it will change from a negative exponent to a positive exponent. So when you're working with exponential expressions, here's a couple of examples. We could have negative 20 to the 0. Like I said, anything raised to the 0 is 1. But one thing they will try to trick you with is if they put a negative in front of the parentheses. Only the part that is attached to the 0 becomes 1. This negative would still be here, and then the 2.34 to the 0, that part becomes 1, so that becomes a negative 1. They could also give us our negative exponent. Let's say we have 7 to the negative 2. We can make that a fraction, and this will flip. We have 1 over 7 squared. They could leave it like this, or they may want you to multiply the 7 squared out. 7 squared is really 7 times 7, so 1 over 49. One last example of these is 5x to the negative 4. So when we do this negative exponent, again, it's only going to be attached to the letter or variable that it's touching. The 5 does not have an exponent of negative 4. So only the x over negative 4 gets put over 1. The 5 is still here. Now this was really 5 times x to the negative 4. So when we flip the x to the negative 4 and the 1, this is still times 1. X to the 4 will stay positive. Well, will become positive once we've flipped it. So 5 times 1 is 5, and x to the 4th will stay x to the 4th. We can't simplify any further because they didn't give us a number for x. So the second part of exponential expressions is they will give you some variables to work with, and they will tell you what the variables are. So we want to simplify this when r equals negative 3 and s equals 4. So I'm going to plug in the numbers first. I'm going to replace r with negative 3. And then we know this is really multiply. When you have two variables next to each other, you're really multiplying. And I'm going to replace s with 4. Now we worry about our exponents. We know that negative 2 attached to the negative 3 would make this a fraction and flip just this. Again, the negative sign in front will not move. It's not attached to the negative exponent. And keep in mind, when you flip this, only the exponent will change to positive. We have negative 1 over negative 3 squared. The negative 3 is not an exponent, so it will stay negative. Only the exponent changes to positive. And then still times 4. So now we can simplify. Negative 1 times 4 is negative 4. Negative 3 squared is really negative 3 times negative 3, which would come out to be positive 9. So that would be negative 4 over 9. So let's just do one more example. Five r to the third s to the 0 when r equals 5 and s equals negative 1. So again, we replace the variables with the numbers they told us they equal. We have 5. We're going to replace r with 5. And replace s with negative 1. This time we don't have any negative exponents, so we're not going to have to do the fraction stuff. All we have is this 0, and we know anything raised to the 0 becomes 1. So we have 5, parenthesis 5 to the third, well, either parenthesis 1 or times 1. Doesn't matter really which way you read it. So now we can multiply this out. 5 times 5 to the third really means 5 times 5 times 5. This all came from the 5 to the third times 1. So if we multiply this all together, we get 625. So that concludes our discussion of exponential expressions.